Hello everyone. Our today's topic is combination of resistors. What do you mean by resistors? Resistors are basically resistance we know, which are symbolized by this R. Now, combination means you can combine two resistors with each other. Means if R1 is a resistance and R2 is another resistance, we can just add them in different ways. Why is it required? Now sometimes you need some special values of resistance like 25 ohms, 45 ohms, which is not available in the market. So you need to add those things which is available to find your desired value. Now, will we just join them normally, or there are some specific rules to do that? Yes, there are two ways to combine resistors with each other. If I classify these methods of combination, we can get two methods. There are two methods of combining them. The first method is very easy, it's called series connection, and the next method is called parallel connection. I hope a lot of the students have already heard about it. The question appears, what makes these two connections different from each other? If we are talking about series connection at first, the series connection is basically joining one resistor after the other. Means if I am given two resistance R1 and R2 and we are asked to join them in series, I will just take one resistance R1 like this, and where the first resistance ends, like here, I will just join the next resistance R2. And if I am given more resistance like this, I will just keep on joining them one after the another. So you can see in series connections we join one resistance after the end point of another. So one point is free and the end point, the first and the last points remain free. Is R1, R2, R3 and so on. Now what is the value of this combination? If I just join R1, R2 and R3, what is the net value I will get? The net value of after combination you will get is R equals to R1 plus R2 plus R3 plus so on if you add more. That's like if you join two resistance like this, 2 ohm resistance is joined with another 4 ohm resistance, then there will be just two resistance. Their combination value will be 2 plus 4 ohms, that is 6 ohms. If you join more than that, if you have a 5 ohm resistance joined with another 7 ohms resistance and added with a 15 ohm resistance, the combination will give you 5 plus 7 plus 15, that is 27 ohms. So it's basically basic addition of resistance, nothing special than that, nothing better than that. So it's a very simple method of doing this. What are the few properties of this combination? In case of series connection, we can join multiple number of resistance like this with a circuit like this. Clear? We can also add more things like here, where the Ohm's law suggests that V equals to IR, where the R of this circuit is basically R1 plus R2. Clear? We must need to remember that the specific characteristics of series connection is that through every component, that means through every resistance, it is might be R1, R2 or 15 R15 R20, it doesn't matter how many you connect, through every component current flow that is I, will be constant. That means through R1 also I current flow is happening. Through R2 the current flow value is also I. But potential difference will be different for each case. So if I current flows through R1 and I current flows through also R2, what can I know? Let's look at the R1 resistance. Through R1 resistance, the current flow is I. So potential difference I can calculate. Potential difference for R1 resistance is how much? If I name it V1, then I into R1. Just like following Ohm's law, I current flow, R1 resistance. So potential difference current into resistance. Similarly, potential difference for R2, V2 equals to I into R2. You can see I is same because through every component current flow will be constant. Now if I had more than this resistance, I will write this V1, V2, V3, V4 and will just add them out like this. That's like if I had another resistance, it will be IR3. So you can see here we have two resistance V1 and V2 are their corresponding potential difference. Now these two V1 and V2 are actually coming from V. So I can say that total potential difference V is basically V1 plus V2. Now what do we know from Ohm's law? That V equals to IR, where R is the total resistance. Now I can write that V equals to V1 plus V2. So I can write V equals to IR. What is the value of V1? IR1. The value of V2? IR2. So from here I can take I common. If I take I common from these two, I will get I into R1 plus R2. So what I am getting? IR equals to I into R1 plus R2. This is the equation we get. If on the both sides I cancel I get my final equation. I get my final equation that R equals to R1 plus R2. This is the method of calculating the formula. This is how the formula of series connection was derived in physics. Clear? So if I had more than this, then V3 equal to I3 R3 I4 R4, I would also get I into R1 plus R2 plus R3 plus R4, and R will also be R1 plus R2 plus R3 plus R4 and so on. Clear? So in these cases we will be just adding up their values. Now let's say that if I have multiple number of series connections of same values, that means all resistance are of R ohms, and I have joined a huge number of them. If I have joined n number of resistance, then what should be my total resistance in series? Now total resistance in series, R will be n into R. That means n number of resistance into value of each resistance, that is R, will give you total resistance. This formula is very easily calculatable. Just like for if I just add 4 resistance, each of 3 ohms. Each of 3 ohms, I have added 4 resistance. So what should be the total resistance? The number of resistance is 1, 2, 3, 4 and each resistance is 3. So NR, that is 12 ohms. This formula is very much easy to calculate short questions and numericals. Okay, so this is all about series connections. In the next video we will learn about parallel connections. Thank you.